Hi folks, today's lesson is looking at distance, speed and time. So let's crack on and get the job done. A lorry's travelling at 30 miles an hour for 2 hours. So in its first hour, it will travel 30 miles. In the second hour, it will travel 30 miles. Altogether, that's 60 miles. Two lots of 30 miles, 60 miles. And in this example, we are using the distance travelled equals the speed times time. Here's a plane travelling at 200 miles an hour for 3 hours. So after the first hour, it will have travelled 200 miles. After the second hour, another 200 miles. And in the third hour, another 200 miles. So we can see that's 3 lots of 200 miles, 600 miles. And in our last two examples, we've used, in both cases, that distance equals speed times time. So in this first example, we've got an object moving at 20 miles an hour for 3 different time periods. Now, in each case, the time given to us is in hours, and the speed given to us is in miles per hour. So the units of speed and time are consistent with each other. And it's really important that we check that, because once we are sure that the units are consistent with each other, we can use the result distance equals speed times time. So in part A, the speed is 20, the time is 2. That's 40 miles. Notice the units are miles, because in our unit of speed here, we're given miles per hour. In part B, using distance equals speed times time, 20 times 5, 100 miles. And finally, distance equals speed times time, 20 times a half, that's 10 miles. In this second example, we cannot simply start using distance equals speed times time. Because if we look, the units of time are given to us in minutes, but the units of speed are in miles per hour. So they are not consistent with each other. So the first thing we must do is make the units consistent with each other before we can use distance equals speed times time. So in part A, 15 minutes is a quarter of an hour. In part B, 20 minutes is a third of an hour. And in part C, 100 minutes, 100 divided by 60, is 1 2/3 of an hour. Now our units of time are consistent with our units of speed, so we can use distance equals speed times time. In part A, 36 times a quarter, that's 9 miles. In part B, 36 times a third, 12 miles. And in part C, using distance equals speed times time, 36 times 1 2/3, 60 miles. We've established that distance equals speed times time. If we divide both sides by speed, we end up with time equals distance divided by speed. And that's what we're going to be using in the next example. In this example, we're given the speed and the distance, and we're trying to find the time. In previous examples, I've talked about checking that your units are consistent. In this example, the speed is given to us in miles per hour, and our distances are in miles, so the units are consistent. Therefore, we can simply use time equals distance divided by speed. That's 80 divided by 40, and that's 2 hours. It's hours because our units of speed are given in miles per hour, and it's the units of speed that will determine the units of time. In the second example, time is distance divided by speed. 60 divided by 40, 1.5 hours. And in part C, 90 divided by 40, that's 2.25 hours. Previously, we have rearranged distance equals speed times time to give us an expression in terms of time. However, if we divide both sides by time, we get a new arrangement. Speed equals distance over time. And that's what we'll be using in our next example. Using speed equals distance divided by time, in example A, 50 divided by 2 is 25 kilometers per hour. Note the units of speed kilometers per hour are given to us by the distance being in kilometers and the time given to us in hours. So it is the units of distance and time that determine the units of speed. In the second example, again, speed is distance divided by time. 400 divided by 50, that's 8. And check the units. Meters for distance, seconds for time. So it's meters per second as our units for speed. And in example C, can we just think what the units are going to be before we do the calculation? Well, the distance is centimeters, the time is in seconds, so it will be centimeters per second. Distance divided by time, 2 divided by 8, 0.25 centimeters per second. You may find it more helpful and quicker to use the distance, speed, time triangle. If you are using it, you need to have distance on top, speed to the left, time to the right. How would you use it? Well, in example A, we're trying to find the speed. So we put our finger over the S in the triangle, and it leaves us with D on top divided by T underneath. That's telling us that speed equals distance divided by time. We can then simply substitute our values in, and 32 is our answer. Note the units, meters per second, because the distance is given to us in meters, the time given to us in seconds, so meters per second is the unit for our answer. In part B, this time we are looking for the distance travelled by the object. So we would put our finger over the D for distance, and that leaves us with S and T. Now S and T are next to each other, and mathematically when two letters are next to each other, we know that would mean multiplied by. So its distance is speed times time. We then can simply substitute our values in. Note we just check. Speed is given to us in miles per hour. The time is given to us in hours. So these units are consistent. We can simply multiply the values together. And 350 miles is our answer. And our final example using the distance, speed, time triangle. This time we're trying to find the time. So we put our finger over the T in our triangle. That leaves us with distance over speed. So time is distance divided by speed. Put in our values, and quite significant values, and a quick check of the units, kilometers and kilometers per second. So the units are consistent with each other. and therefore 150 million divided by 300,000, that gives us 500 seconds. In actual fact, if you're wondering why we've chosen such large values, 150 million kilometers is the distance from Earth to the Sun. 300,000 kilometers per second is the speed of light. So in actual fact, it takes 500 seconds for sunlight to reach the Earth. I hope you've understood the interaction between distance, speed and time. Make sure you check your units are consistent. That is really important. Use the distance, speed, time triangle if you think it's more helpful and quicker for you. And if you've understood everything in today's lesson, then you've got the job done.